Welcome. Today, we're going to go way beyond the buzzwords to understand how these huge, large-scale AI systems are actually built. And I'm not just talking about the models. We're talking about the entire ecosystem.
So here's what we're going to cover. We'll kick things off with a pretty cool metaphor to help frame our thinking. Then we're going to dissect the core anatomy of these systems. After that, we'll explore two fundamental genetic blueprints for building them, learn their survival instincts, and finally, check out some really fascinating examples out in the wild. Okay, let's dive right in with the core idea that's really going to guide everything we talk about today. We so often think of an AI model as just the brain. But a truly functional AI is a complete ecosystem. It's got all these different interrelated parts that have to work together perfectly, just like in any living system. It needs a way to sense the world, to process information, and then to act on it. So, if we're going to run with this idea that it's an organism, then what are its organs, right? What do they all do? Let's break down the anatomy. Every AI organism has this fundamental flow of intelligence. It all starts with sensing its environment by taking in data. That's ingestion. That info then circulates through data pipelines, gets processed by the AI models, the system's brain, and then finally, the organism acts on the world through APIs. That's how it speaks and interacts. Think of data pipelines as the circulatory system. Seriously, they're constantly pumping the nutrients, the data, that this organism needs to function, to learn, and to stay healthy. Because without a steady flow of clean, reliable, up-to-date data, the whole system just starves. And this right here, this is the central nervous system. The orchestration layer is the glue that holds everything together. It's what automates all the critical tasks, like scheduling when a model should train, and it coordinates these really complex actions between different AI models. It's what turns a collection of separate parts into one unified intelligence system. So we've got the organs, but how do we actually assemble them? Well, it turns out there are two primary genetic codes, or blueprints, that every architect has to choose between. And this slide really gets to the heart of it. The monolithic approach is kind of like a starfish. It's a single, self-contained organism. Super simple to get started, but an injury to one part can threaten the whole thing. But then you have microservices, which are much more like a beehive. It's a collection of small, independent specialists. If one part fails, the colony just adapts and keeps on thriving. So, why does this matter so much? Well, for these huge, constantly evolving systems, think about Netflix. Breaking things down into microservices is pretty much the only way they can scale and innovate quickly. If their recommendation engine needs more power, they can scale up just that service without ever touching the billing system. That fault isolation and flexibility is exactly why it's become the go-to blueprint for any serious AI system. Okay, an organism needs more than just a body, right? It needs a set of core instincts so it can survive and thrive in a world that's always changing. For an AI, these are its design principles. These 5 pillars are basically the core DNA for any AI that hopes to make it in the long run. Modularity just means it's built with interchangeable parts, like Legos. Interoperability is how it communicates with other systems out there. Fault tolerance, well, that's its immune system, letting it recover when things go wrong. The human in the loop is its connection to a guide or a teacher. And compliance and security, that's its ethical code and its self-preservation instinct. So this is absolutely crucial. Humans have to stay part of the system. I mean, take Tesla. They famously use a massive team of human labelers to review challenging video clips from their fleet. Those people create the high-quality ground truth data that is absolutely vital for training accurate self-driving models. And this brings us to a critical survival challenge for any AI organism. It's an issue we call model drift, and it's basically when the patterns the AI learned in training just don't match the new reality it's seeing out in the wild. And here's the solution, and it's a fundamental truth of these systems. A successful AI organism has to be able to heal and adapt. And that means you have to build in the capacity for continuous monitoring and retraining from day one. Maintenance isn't an afterthought. For an AI, it's a core biological function, like breathing or sleeping. All right, let's move from theory to the real world. We're going to go examine two very different organisms out in the wild and see all these principles in action. First up, Tesla's self-driving ecosystem. This thing is like a highly specialized predator. It's got lightning-fast reflexes at the edge. That's the custom computer in each car making decisions in milliseconds, right there on the spot. But it also has a hive mind, with the entire fleet sending back tricky scenarios to a central brain so it can continuously learn. And for safety, its brain actually has two parts running in parallel to cross-check each other. Now, in complete contrast, you have an open source stack. This is more like an adaptable creature that's built from a community gene pool. Instead of one company building everything, it's put together from all these best-in-class components. You have tools that act as the organism's lab notebook to track experiments, others that serve as its genetic record for versioning data, and even vital sign monitors that are constantly checking the system's health. The key here isn't the specific tools, but the incredible flexibility you get with this approach. So, what's the crucial point in all this? Whether you're looking at a highly integrated, specialized system like Tesla's or a modular, flexible one built from open source parts, the underlying principles are exactly the same. A successful AI isn't just a static model, it's an integrated, living ecosystem that is designed from the ground up for continuous evolution. And that leaves us with a fascinating question to think about. As these complex systems continue to grow and learn and interact with our world, what new forms are they going to take? What new capabilities will they evolve? The architecture that we build today is the DNA for whatever comes next.